Let me know.
No.
Okay, so thank you. The perhaps slightly provocative title of this talk is "Who needs manual testing anyway?" which is a question worth asking, because these days we're automating just about everything, right? And let's see if I manage to switch slides. Yes, I do. So for the next 30 minutes, let's start with a bit of an introduction. Who am I anyway, and why is this an interesting thing to consider? Let's start with thinking about what are we automating anyway. When we're talking about test automation, what is it we're automating really, and what is it that we are not automating? And then we'll consider means and ends, and particularly how, when ends are not very clearly explicated, how means sometimes tend to morph into being ends. Then I want to raise something with you that I termed Darwinistic development. It's not an established term by any means, but bear with me and hopefully it will make a little bit of sense. And then ending on a perhaps slightly sad note, we're going to say farewell to DevOps. And then, as any respectable talk, we'll end by looking ahead a little bit. So my name is Daniel Ståhl. I spend most of my time at Ericsson at a group function called Group Function Technology, ostensibly a subject matter expert, which means I think about things and study things such as how we might improve as a company with regards to development practices, how we might improve with regards to continuous practices, how we might improve our software product quality, protect our supply chain integrity, and that sort of thing. I also do a little bit of research. I'm one of the researchers in project number 6 in Software Center. I have been known to write books on occasion, and I received my PhD from the University of Groningen. But these days, I'm also associated with Linköping University as an associate professor. So that's me. Now, a bit of a spoiler alert. The punchline of this talk will be that who needs manual testing? Well, we all do. Everybody needs manual testing, at least for the foreseeable future. But this is not an anti-automation message either. So it's not anti-manual testing, it's not anti-automation, but rather an opportunity to reflect on what happens if we forget why we automate testing and what it really means and what we might be missing out on if we do that. So this is not any, reporting of concrete research findings or anything like that. It's a little bit of let's think out loud about these things and see what happens kind of thing, which I also think is a worthwhile thing to do at a reporting workshop. We'll save the actual research results for after lunch. And also, this is not about your company in particular, or not my company either. It's more of a reflection of the state of the software industry as I perceive it. There's a lot of noise, so someone is not muted. Perhaps you could look that over. That would be awesome. Thank you. So let's consider, what are we automating in the first place? One way of thinking about this is we have this information space of what we might think of as explicated requirements. Things that we have captured and phrased somehow. We have put them into our requirements database or software requirement specification or whatever it is you use that tell us what the system we're developing should behave like. There's a subset of these requirements which we might think of as being automation friendly. The point being that not every requirement is very automation friendly. This could be for various reasons. It could be because the requirements are not or cannot be phrased in the clear quantitative fashion that makes it easy to automatically determine what a successful outcome looks like. It could be because they require particular circumstances, a particular execution environment that is difficult to replicate or simulate automatically, or for many other reasons. The point being that the automation-friendly requirements are a subset. It could be a very small subset or a very large subset. It depends on the context, obviously. And also, this is particularly true at a complex entire system level. It's not so much the case when we're talking about a small simplistic component, or I'm writing my Java class or what have you, but it is when we build these very large interconnected systems with more or less emergent properties that it becomes more and more difficult to automate all of our requirements. But outside of this space, we also have a larger space of what we might think of as implicit requirements, things that we did not capture that might be obvious to the customer or the user, that they might phrase upfront, but that we failed to capture, or we captured inaccurately. So admitting the fact that requirements are fallible. They can be incomplete, they can be incorrect, just like anything else we do. We have a space outside of the actual explicated requirements. That is nonetheless important because they reflect how the system ought to behave in some sense. And outside of that, we have an even larger space of what we might think of as latent expectations. Things that the customer wouldn't even phrase themselves. I know it when I see it kind of stuff. Once you are interacting with the system, you encounter something and say, well, that's not what I expected. That's not how it should work. It's not something I would have thought about up front, but in that interaction with the system, I discover, actually, I explore my own expectations in a sense. And this is obviously very, very difficult to address with automated testing. The point being here that the scope of automated testing is primarily the innermost core of this space. And when we talk about automated testing here, we are mostly thinking about, or I am mostly thinking about, the traditional kind of scripted static verification of requirements. It is not the be-all, end-all of automated testing. Let's be clear on that. There are other techniques. We can talk about chaos engineering. We can talk about lineage-driven fault injection. We can talk about various randomized techniques, which change this picture a little bit. But I think for most of us, it is true that the vast, vast bulk of the automated testing we are doing in our software pipelines today is this scripted verification of requirements. So that is what we're primarily concerned with here. Now, let's agree, I hope, that this dynamic interplay between a critical mind, and to be clear, we're talking about a critical human mind today. In the future, where we are all replaced by strong artificial intelligence, this is going to be a moot point. But today we're talking about a human mind. So the dynamic interplay between that mind and the system behavior is key to identifying that which we did not anticipate. And this is important because you can think of a requirement as being the identification of something, some state, some way the system needs to behave that could plausibly, conceivably be different, which would be bad and which you would consider to be a fault. So in a way, a requirement is the flip side of an anticipated fault. And anticipated is key here because we are not necessarily all that good at anticipating everything that can go wrong. Very often, your mileage may vary, but I find that very often the things that trip us up in the end are the things we did not anticipate, that we actually did not have requirements for, but in the end, they hurt us just as badly. So this is worth keeping in mind as we also think about means and ends, because it's always worth thinking about what is the actual end which we serve by automating tests. This should be an obvious part of any test strategy, say, but in my experience, very often it's not actually made clear, and even more so, it's not being made clear to what extent those ends might actually be within reach. For instance, are we automating to improve efficiency or to improve quality or to or for some other reason? And how much of our test scope should we actually automate? How much is reasonable to automate? Is it 100%? Is it less than 100%? Because something to be aware of is, as we go along and create larger and larger test scopes, we create OpEx for ourselves. We have a larger and larger set of tests which needs to be maintained and updated as the product evolves, and it requires more and more infrastructure and therefore cost to keep executing. So to paraphrase Oscar Wilde a little bit, you could question whether the automation is expanding to meet the demands of the expanding automation. But a way to think about this is, let's say you have a test scope, and you can map that onto an axis. Say, this is my entire test scope, all of the test cases that I would like to execute manually or otherwise. And on the other axis, we have return on investment. What would be the return on investment for automating that? And at some point here, you're going to essentially break even, and at some point, you're not going to break even. And in such a space, you will have a distribution. You will have test cases which are very easy to automate. It's very straightforward, and this is where you typically start. As we embark as organizations, as companies, as projects on the journey to automate our test cases, we tend to start in the easy end, and that's natural as it should be. Of course, we start there, and so we tend to see, very happy days early on with a lot of progress. We automate a lot of things, we gain a lot of efficiency, and things are looking really great. But as we move along, we need to, start digging into test cases that are not so easy. And actually, we tend to kind of see a slowdown of progress where we do not make as much progress as we did earlier, partly because we have racked up a bit of OpEx that we need to carry along, but also because the tests become more and more difficult to automate because we have already had the easy pickings, if you will. And at some point, you're going to end up with tests that are really, really hard, and where you might begin to question whether it is actually worth the effort to automate them in the first place. Now, again, this is not an anti-automation message, but it's quite rare to see this kind of discussion actually. Very often it is more or less an implicit assumption that the ambition is to automate everything. And that is not necessarily a healthy attitude. And thinking of this as a researcher, I think it would be very, very interesting and valuable for practitioners, for engineers, for test managers to have a model, a tool similar to this, where we can actually make fact-based decisions and try to analyze our test scope and discuss what is our automation ambition, how much of the test scope should be automated and which parts should not be. Are we talking about 100% automation or less than 100% automation? Maybe it's actually far less than 100%. So if we're thinking about relevant research questions going forward, I would actually put this up there as something that would be worthwhile looking into. And in that spirit, if you think what I have said so far is fairly uncontroversial and nothing to get excited about there, and now we're getting farther into the crazy spectrum, and I'm actually not entirely convinced by this myself, so I'm very eager to hear your thoughts on this because I really want to bounce this off of you. Let's call this a quiet curiosity of mine. It's a bit of an observation that we talk a lot about rapid feedback from automated test suites and how that is extremely important for the developers to be able to do a good job. As a developer, you want confirmation that you didn't break anything. We run our regression tests to make sure that what worked yesterday also works today. But not least reflecting on my own behavior actually as a developer and how I tend to react in the presence of such test suites, is that this enables a particular style of software development, which you might think of as software by trial and error. We make a change and we, throw it out there, expose it to reality and see if it survives. Thus, Darwinistic development. And this is all good. It's, if nothing else, it is an extremely convenient way of working because it enables me to, let's say I'm looking at an API and I want to use that to implement my feature. It's an API I'm not very familiar with. It enables me to, rather than read through the documentation and try to understand the thinking behind it and the kind of expected user scenarios, and maybe reach out and talk to some of the designers behind it and discuss how might I best implement my feature to achieve my purposes using this API, which is all very hard work. I can rather explore it by testing, by trying it out, seeing, should I do it like this? What happens then? Did I break anything? Nope, that's probably okay then. And then trying something else, and then some tests fail, and obviously that was the wrong thing to do, and so forth. So I kind of move forward in that exploratory sense, which has many benefits. It can be a very effective way of working, but it may come with certain risks as well. And it's reassuring, as developers, we really like to get this feedback, the green light, the red light, did I do something wrong or not? Is everything working? And it's very easy to get into a state of mind where that feedback is taken as a substitute for things actually working. And it's very easy to get into the habit of trying things out rather than thinking things through. Because I think the problem here, potentially, and again, I'm just throwing this out there, the problem might be that there's a hidden assumption behind this. And that is, when we do this, we assume that the tests tell the truth and nothing but the truth. And that's fairly uncontroversial, I think. Most of the time, we can assume that to be the case. Let's assume there's no such thing as flaky tests and so forth. But we also assume that they tell the whole truth. And actually, at least if you are on board with me on the previous slides, that's not really the case. So I'm a little bit interested in if we can dig into this. I would, again, as a researcher, I think this is a very interesting topic, and I would be very keen on seeing, can we investigate this somehow? Is there something there, or is this just completely unfounded and meaningless to worry about? Could we perhaps look at developer behaviors in the face of such test suites and any correlation with, say, in-service faults detected or something like that? That would be very interesting, because I'm a little bit worried about this myself, but not completely certain. So I would love to hear your thoughts on it as well. But something else to consider is DevOps. What happens to DevOps when we focus extremely on automating testing? Because we all love DevOps. We don't necessarily agree on what DevOps is. There are many interpretations of DevOps, but whatever it is, we like it. And most of us agree that automation is a big part of achieving it. But what happens when the pipeline we use to build and test and package and deploy the product is actually more automated than the product itself in service? Because we would all like to think, at least, that we would like to imagine that our products are these perfect, pristine, plug and play, zero touch things that are extremely reliable, require no manual intervention whatsoever. But what happens when that is not the case? Because in my experience, at least, sometimes they do break, even if we would like to think of them as these perfectly automated things. Sometimes they do require manual troubleshooting. Sometimes they do fall over and require manual intervention. And the thing here is that I think it's becoming quite clear that automating the pipeline in R&D, automating the building and testing and packaging and deployment of the software is an easier problem than creating this zero-touch plug-and-play product that we don't really need to touch in service. And then what happens when we are so automated in R&D, but not quite there yet in service? I think something that has began to become clear to me, at least, and I have picked up on similar reflections elsewhere as well. So I think there might be something to this, that removing the manual testing by automating the pipeline, when we do that, we remove a lot of the manual testing we used to do once upon a time. When we do that, we actually remove the opportunity to learn operations in R&D. So our developers are actually farther removed from operations as a consequence. And here I think there is a deep irony in our struggle to achieve DevOps, not least through automation. So you could think of it as, this pipeline actually turns into something of a wall in between Dev and Ops, because through our efforts, we end up creating a cozy bubble in which we put our developers. A cozy bubble where the workflow is essentially, I check out my code, I make the changes, I run my tests, I check it in, everything is working, it builds and it deploys automatically and all the green lights are on. And they never really interact with the system actually in service. And so when they do fall over in service and we do require that manual troubleshooting, that manual operations, there are fairly few people who actually have that experience. So this again, I think, is an interesting topic for future research, one I would be very happy to dig into myself. Or if this is of interest to you guys, or if you just have reflections on this, I would love to have a conversation. Because this is potentially a risk we are exposing ourselves to unwittingly by traveling down this path. But let's look ahead a little bit. Let's be more positive. I think the point to be made here is not that we should, completely realign everything we're doing. We should keep thinking about how to improve our automated testing, not least testing beyond requirements, as it were, more sophisticated techniques. We mentioned a few earlier. There are others, ways in which we can kind of expand the scope of automated testing and address more than just this smaller subset of requirements. But we should also, I believe, pay more attention to the boundary between automated and manual, because like it or not, manual testing is going to be with us for the foreseeable future. We're not getting rid of that. So we need to think more about how does automated and manual testing complement one another in a good way? What are the actual values we aspire to? Can we quantify them in some way? And how do we apply one approach or the other in a given situation? What are the guidelines? What are the models we might apply to solve that problem, to understand, well, here is clearly a case where we should use manual testing approach X, and here is clearly a case where we should use automated approach Y. So that, I think, is a very important topic going forward. And also to resurrect the conversation on effective manual testing practice. We need to get out of the paradigm that has been prevalent for a number of years now, where, essentially there is a view that the only good manual test is one we haven't automated yet. I think that is quite harmful. So we need to start thinking again about how we can make the best out of these wonderful, brilliant testers we have in our organizations, not just treating them as the people we didn't get rid of yet, but rather how can we make the most of that? What are the sophisticated manual approaches where we can get the most value out of their time? Because we're not talking about rote verification of requirements, following a script, push that button, type in this command, see if you get this output, check that box. Nobody wants that. That's not what we're talking about. But how can we get the most value out of the manual testers? Because they are needed. And of course, how can we better build quality in? We all like to say, you can't test quality in, you have to build it in. That's all true. And perhaps by thinking more broadly about the problem than just automating tests, we can refocus a little bit on how we make sure we get a high level of quality in the first place before testing. So those are some random thoughts. I assume you will not agree with all of them, but that's why we're here, right, to have a conversation. So thank you very much for listening. I hope this was of some value to you, and perhaps we will see each other after lunch when we will be a little bit less philosophical and more down to earth with actual research findings. So thank you.